High-strain fitting connections. Take out the high-strain dispenser. There are 4 ports on the side. VE, VR, FE, FR. VE/VR connected to high-strain accelerometer. The interface is 4-hole. Notch on the joint tighten the notch insertion. After VE/VR is connected, FE/FR connects the stress ring. The interface is 5-hole. The same notch is tightened for notch insertion. The connection to complete. Next, connect the high-strain cable. Unscrew the protective cover on the adapter. Insert the same notch to the notch and tighten the cable. Connect the other end of the red dot to the host accessories. The connection to complete. High-strain operating settings. Power on. Enter the boot interface. Click English to switch between Chinese and English. Switch it to English. This device has 2 modes, low strain and high strain. First, high strain. Click RS to enter high strain mode. There are 2 choices here, general and railway versions. Generally choose the generic version. Click Settings to enter the settings screen. Go to the settings screen. The first is engineering parameters. Enter the project name as required. Here is the flow number. Here is the registration number. The serial number and the registration number are uploaded. If you do not upload, you cannot fill in. Click New to enter the project name. Type on the keyboard. This is case switching. This is the left and right cursor keys. This is a clear screen. After clearing the screen, you can re-enter the value. Click OK. Back to the engineering interface. Serial number. The habit is to enter the date of the day. Let's say we are January 1, 2018. This makes it easier to experiment. If you don't upload it, you don't need to fill it in. The certificate number can be default. It's the pile. Addition and subtraction can quickly adjust the pile number order. If the sticks are next to each other, it saves time. You can also click to enter the pile number. Enter a name. Click OK. The following are the sampling parameters. The pile parameter. Here is the pile length. His coefficient. Measuring point cross-sectional area. This is the elastic wave velocity, the pile density. Here are some other parameters. Among the other parameters, the first is the length of the pile, the total pile length. The second is the length of the soil pile. The pile length in the soil is the pile length below the mounting sensor. This is the average wave speed. Here is a concrete strength of the pile. Enter as needed. You can choose the pile type here. The first is a round pile and the second is a square pile. The third is a pipe pile. The fourth is the outer inner circle. The one with the outside and the inside circle is rare. The general choice is round pile and square pile. Select the round pile and click Enter diameter and the cross-sectional area. After diameter input, pile area and perimeter are calculated automatically. Don't have to enter. If it is a square pile, enter the length and width. Enter length and width. Length 600 and width 800. The cross-sectional area and the perimeter are all calculated automatically. Don't have to enter. The input of pipe pile is outer diameter and inner diameter. Parameters of pile bottom. This is the diameter of the pile and the cross-sectional area. Enter complete. Click OK. Below are the hammer parameters. The first is the hammer weight. The second is the fall distance. The third one is penetration. Fill in as much as the hammer weighs. The drop distance is the distance of the hammer from the head of the pile. The third one is penetration. Just follow the default sampling parameters. The first is how it's triggered. Here are 2 ways to trigger it. The steady-state trigger. Channel trigger. In the actual acquisition process, channel triggering is generally selected. Trigger level. The higher the trigger level, the greater the energy required to hammer. It's usually 30 millivolts. This is the display length. The display length can be 512 or 1024. Sampling interval. The sampling interval is generally based on the pile length. For short sticks, we use 4896. For long piles, it also has the pile length suggested sampling interval. Fill it out according to the suggestions. Automatic calculation, automatic saving. This is low-pass filtering. This is the percentage of battery. Sampling parameters are set. The following are the system parameters. System parameters are mainly set. Sensitivity of a sensor. The sensitivity value. There are 4 sensors to acceleration sensors. The sensitivity is on the verification certificate. Just put it in. If there is no test, the certificate will be provided above. That sensitivity from the factory. The top 2 are accelerations. The last 2 are the sensitivity of the stress ring. And then this is the choice of computing channel. This is the velocity channel. There are 3 kinds of. The first one is the average. This is the speed of one channel. This is the speed using 2 channels. Normally we take the average. This is the choice of the inverse channel. The inverse channel selection is also the same as the velocity channel. Inverse channel 1, inverse channel 2 and average. And again, the average is generally used. This is the analysis, a default analysis interface. It's usually raw. Of course, you can choose to go directly to the sampling screen. We usually choose to display the original interface. There are more settings below. Up here is a choice of signal polarity. Here is the adjustment factor. These are generally by default. This is the speed channel auto forward. Usually you can check it or not because when you analyze it, it's all adjustable in the software. System parameters have been set. The last is the setting of the wireless parameters. Wi-Fi is what we upload to. Here's the transmission device. The first one is the Bluetooth switch. The second is the upload switch. Yes means upload, no means not to upload. And then the third is the choice of upload method, automatic upload or manual upload. And then this is a state of the server connection. Once you set it up, click OK. Yes, enter on collection screen. The sensor front has been connected. The first one is setup. You can return to the settings page. The second one is surveillance. You can learn about the sensors. Click Start Monitoring. To monitor, you can understand the original state of the stress ring. So let's say that these 2 values are too large. It means that the initial deformation of the stress ring is too large. Consider replacing the stress ring, or your installation is not very standard. The original deformation of the stress ring is too large. It's not good for the rest of the test. So when you're watching, the shape variables of the 2 stress rings should be controlled within 500 microseconds. The closer you get to Lin, the better. The positive and negative is fine after monitoring the condition of the stress ring. If there are no problems, you can start sampling. There are 2 choices when sampling. One is click. One is a combo. For high strain, click. Prepare the site well. Click to select drop hammer. The signal will appear after the hammer drops. After the trigger, watch our signal whether it meets the experimental requirements. If the signal can, you can sample the next pile. If the signal doesn't work, we'll find out why, see what went wrong. And then we do the acquisition again. After the collection is completed, we need to save the disk immediately. Real-time inventory. The first is the name of our project. I just typed it, so let's see if it's correct. Any errors can be corrected here. Pile number, file name. The pile length can be changed here if it is wrong. If that's alright, direct save signal. After the collection process is complete, you can do it here. Here's some simple analysis. You can see as here, a result of keys. Here are the velocity and stress curves. The second is the case curve. The third is keys result. Generally choose to analyze on the program software. On the instrument to analyze, there are some limitations. Instrument is mainly responsible for the ideal signal is collected. After collection, you can plug in the USB disk. to the file management interface. I'm gonna hit copy. Copy it to a flash drive. The acquisition process is complete. Low strain connection fittings. Firstly, the acceleration sensor interface is inserted into the ACCE. Insert red dot to red dot. Then use the coupler. Connect the acceleration sensor and the model pair. Here we use industrial butter. Low strain operating settings. That was high strain collection. Next, low strain acquisition. The first one is our low strain acquisition program. Click to enter the settings screen for low strain. The first is the choice of mode, a universal version and a railroad version. Select the general version as normal. Second, settings screen. Let's go to the settings screen first. The first one on the settings screen is setting engineering parameters. The setting of engineering parameters includes the name of the project. This is the name of the project. New. Click New to create a new project name. And then the second one is serial number and employment certificate number. This is for uploading. You can leave it out if you don't upload it. And below that is the message of the pair. The first is the pair number. The second is the length of the pair. The third is the sampling interval. Pair length. Enter according to construction records. And then the sampling interval, which we are going to calculate automatically. As long as the pair length is entered, the sampling interval will automatically give you a choice. And then here is the choice of cement label. Different cement labels corresponding to different empirical wave velocities. Just pick that label right. The experienced wave speed is also set automatically. Here are the options for pair shapes. The first is a round pair, the second is a square pair, and the third is a pipe pair. Here I choose the pair type, and then this is also a setting for the pair parameter. The second is the superposition mode. There are 3 modes in the sampling settings. The first, same box pattern. The second is the sampling setting. The third is the stream model. The same box mode is recommended. A setting in the same box mode. One is the selection of sampling channels. Acceleration channels are usually used. Here's the trigger. Trigger mode is now disabled by default. And then the third one is the magnification. Let's use a magnification of E or automatic. Now the sensitivity of the sensor is relatively high. Usually use E times. This is a sample length. The specification is cannot litter 2020分钟 mm requirements. The trigger level is normally 30 mV. The number of sampling channels is generally selected as 4. This is the automatic integration of acceleration. As long as you pick acceleration here, he will choose automatically. If you choose speed, he's not going to integrate. This is the setting for sampling. Then there are the display settings. And then we have one here, a ruler of horizontal coordinates. There are 2 options for the ruler. One is depth, one is time. Use depth in daily work. It might be a little bit more intuitive. The first one below is the shadow display. The second is the automatic recognition of lighting. It's usually checked. The third is the power display. This is the selection of sampling points. It's the multi-point. It's still a unilateral point. Generally, multiple measurement points are selected. This is automatic saving. Don't have to check otherwise there will be more invalid data stored inside the memory of. You don't have to check the next one. And then over here is the system time setting. Here are some of the settings for the check. It is usually used in the collection process. And then there are the other parameters. The most important is to include sensitivity of a sensor. Sensitivity of a sensor. On the identification certificate, just type it in. The first one is acceleration, the second one is speed, and then later, the first is the hammer weight. The second one is the cross-sectional area. The third is power density. Some parameters of this interface. It will not affect our data collection. You can use the default settings. Then there's an interface for uploading. This is Bluetooth on and off. Upload the switch. Yes means upload and no means not upload. When you say yes, There is an automatic upload and a manual upload. We are gonna shut it down if we don't upload it. And then we have a server over here. Weather connection. Connect the states above. You can test whether the server is connected. If you don't upload, you can leave all of this out. After all this is set up, click OK. The collection page is displayed. The sampling screen is displayed. It will show you some parameters. The first is piling equipment. It's not set right. It can be here. Project name pile no. If there is a mistake, you can change it again. Mode. One is dynamic. One is the fractional mode. It's usually just dynamic mode. Material selection. There are 3 options: concrete, nylon and steel construction. The site is usually concrete. This is the empirical wave velocity. So let's say we've chosen C30. So the empirical wave speed is 3800. If you need to change it, you can rewrite it right here. This is the pile length setting. This is the sampling setting. I just set it up. Confirm and collect. There are 3 boxes down here. The first integral is sampled. 第二个是指数放大。The second is exponential amplification. The third is low pass filtering. Confirm and click OK. Click on continuous sampling. Install low strain sensors. Strike the tip of the pile to trigger the signal. After firing 4 good signals, click Stop. Click on the Save. Confirm file name. Pile length. Click Save. Next, the analysis screen is displayed. Generally choose to analyze on the program software. On the instrument to analyze, there are some limitations. Instrument is mainly responsible for the ideal signal is collected. In the site to understand the general condition of the pile can be, when the signal is collected, click the file. After collection, you can plug in the USB disk to the file management interface. I'm gonna hit copy. Copy it to a flash drive. The acquisition process is complete.